Okay. Did I this class? Did I give you a post-it a tab for your table of contents? Okay, in your spiral. Okay, so go to that little post-it, your tab, and we need to add this sheet to our table of contents. I think it's number 9 or 8. Can't recall. So add this to your table of contents. I think we're on 9. Now, I think this is the 9th thing. Just go to, like, count how many things you have. I know we have some people at 8, some people at 9. Okay, I need you to highlight the key terms or the key parts to the 2 types of triangles. One, isosceles equilateral. The parts to isosceles triangle, the vertex angle, the legs. The vertex angle is the angle included with the legs. Our base is always opposite the vertex angle. And then we have base angles. And we should have these tick marks that were already given to us. If we have the tick marks, then we can conclude if I go opposite those tick marks, will be the congruent angles. So you can add the arcs on B and C, which means our base angles will always be congruent for an isosceles triangle. All right, so an isosceles triangle is has a triangle with 2 congruent sides or 2 congruent angles. Equilateral is when all sides are congruent or all angles are congruent, but if it's all angles congruent, we call this, I need you to add this to your notes, equal angular. Okay. So based on the parts, I want to see if you can fill in the blanks in regards to the descriptions to the isosceles triangle. See if you can fill in these 4 blanks. All right, we hopefully learned by now that if it's an isosceles triangle, then there's exactly 2 equal sides, and those sides are called legs. And the third side is called the base. Okay? The 2 angles adjacent to the base are the base angles. And the angle opposite the base is the vertex angle. Okay? We're going to make sure you can identify those, use that in some problem solving. All right, so you were given a table underneath our descriptions, our parts. We're going to make sure we can make the correct conclusions based on characteristics and fill in the missing parts. We're going to make sure, I need you to go ahead and label our triangles ABC. The isosceles triangle theorem, we should be already familiar with that special type of triangle in the theorem. So if it's 2 sides of one triangle are congruent, then the sides, or sorry, not the sides, the angles, because they talk about the sides. Then the angles opposite the congruent sides are congruent. Meaning, if you see these tick marks, this was given to you. You have to be given the tick marks to know you have 2 sides congruent. The 2 sides we have congruent, I wrote up here, side AB that has a side or line above it is congruent to segment AC. These are our 2 sides. If those are congruent, what conclusion could you draw? Yes, angle B is congruent to angle C. So if I give you the tick marks, you would give me the angles, the arc marks. So what must be given? What's important? Characteristic. Yeah, we need 2 tick marks. You gotta see that. That has to be given in order to draw that conclusion. All right, so the converse of this theorem, what do we do for converse? Who remembers? It's when you switch your hypothesis and conclusion. You switch the order. Okay, so instead of starting with sides, I'm now going to say if 2 angles of one triangle are congruent, then the sides opposite the angles are congruent. Okay? So on your drawing, your picture, your diagram, they're going to give you the angles. Notice I wrote angle B is congruent to angle C. Then what conclusion could you draw? Yeah, we look opposite. There's my tick marks I'm going to add. So AB is congruent to AC. So what must be given in order to make that conclusion? We need two congruent triangles. Angles, excuse me. Or two arcs. Okay, you need two arcs. Okay, on that part. All right, now, equilateral triangle theorem basically states if a triangle is equilateral, meaning we have the three, all sides are congruent, the three tick marks, then it is also what? Yeah, then it's equiangular. One sec. You should put the door. Thank you. All right, so if I give you the tick marks, you can add the arcs to show the angles are congruent. Now let's think about this. If all the angles are congruent, what's the measure of each angle for equiangular or equilateral? Yep, 60. Make sure you know that by heart. Okay. What must be given to draw the conclusion? Three tick marks. Yes, that's the inverse. That's the converse of that. So basically, if they tell me three arcs, if they show me three angles are congruent, if I know it's equiangular, then it's also equilateral. So they gave me the arc, so now I can add the conclusion of the tick marks. So we need three. We need three congruent angles. Okay, three congruent angles. All right, flip it over when you have their table completed. And we're going to see if we can make the correct conclusion based on the given statement. Okay, so on here, so we're going to use the diagram to complete each statement. It says if segment AB is congruent to BC, then which two angles are congruent? I'm going to go ahead and mark segment A and BC. I'm going to put the tick marks on my diagram. So opposite those congruent sides are congruent angles. So which two angles are congruent? Angle BCA. Yeah, we have to say BCA. Angle BCA is congruent to angle BAC. We can't just say angle A because there's more than one angle with that vertex. So if you just said angle A, that would be incorrect because I want to know which angle you're referring to. Sit up. Get your head off the desk, please. Thank you. All right. Now, we have angle EAC. I'm going to put double arcs to show that angle. If I have angle EAC, congruent to angle ECA. So I'm now looking at the triangle in the interior of triangle ABC. Then what two sides are congruent? We look opposite. AE with the segment line or line over it is congruent to EC. So I can add the two tick marks to show those are congruent. All right, examples in practice. We're going to find the value of x based on the given information. All right, on this first one, number one, what do you see? What do we know automatically? We have equal angles because we have the tick marks, okay? So because we can go ahead and add the angles. What are the angle measurements now that we know that? They're all 60. So automatically y equals 120. Sean, how did you get that? You're absolutely right. Okay, he used this line right here. It's a linear pair, 180. And so we could just say 180 minus 60. Is that the only way to get the answer? Yeah, we also have, this is what type of angle right here? Angle Y. Yeah, it's the exterior angle. And the exterior angle, if I look at my remote interior angles, which here, look at that. So I could say and get to angle Y just by doing 60 plus 60. Okay? All right, but how are we going to get to X? What do we know? Okay, so this, basically, since we already know he's going to, because this is 8x minus 12. We know that that degree is 60. It's equal to 60 for that angle. So he's going to go ahead and just add the 12. Get 8x equals 72, and then divide it by 8. Yes, x equals 9. Okay. All right, so now we're going to do some problem solving because we're going to have overlapping triangles on number 2. All right. They want us to find the variable x and y. First, decipher, we got to figure out which variable is probably easier to find first. Yeah, x is the easier one. Okay, how are we going to get to x? What do we have to use to get to this angle here? We have this 90 degrees. All right. Now what? How are we going to get to that x? Huh? We have two congruent sides in this triangle. So it's isosceles. We have basically a right isosceles. You're right, Adam. How'd you get to 45? We already have 90. Then divided by 2. Yep. So x is 45. Okay. So I'm going to go ahead and put 45, and I'm also going to put it 45 here to show my two base angles that are 45. I'm going to go ahead and label the 45. All right, now we need to get to y. I want you to understand y is just this little sliver right here. It's that little acute piece. Okay, what else do we see that we can maybe use? 60, okay. That means if I have this 60, I knew that was going to happen. If I have the 60, we have an equilateral triangle. Even though we have two tick marks, think about that. If I already know the vertex is 60, the other two have to be 60. All right, so go ahead and try to get y using that 60. Yeah, 15. We should have 15. I'm going to do this. All right, I'm going to go to, I know what I'm going to do. All right, hopefully we're starting with this 50, this isosceles triangle here. Get the x. I know it doesn't look to scale, but we have two tick marks, so we're using that. We should have 65 for x. I'm going to go ahead and put that inside the triangle. 65, 65. Okay, how are we going to get to y? Yeah, use minus 180, so that would give me the linear pair, the adjacent. This is 115. Now what? Yeah, the second one is also isosceles. This one's isosceles, so I know these two angles are congruent. So basically, minus 115 divided by 2, right? We should have 32.5. Questions on that? Because the two base angles in an isosceles triangle are congruent. All right, now, look at example 4. Yes. What do you know it's an example 4? We should see it's an isosceles triangle. So what do you know? Yeah, B and C are congruent. All right. But here's the misconception, okay? Do we have values or expressions inside the angle? No. So if I had something inside, then I would use angle A, B, and C. Where are your expressions? Outside. So if it's on the outside, it's talking about the sides of the triangle. So what do we know about the sides of the triangle? We should see that AB is congruent to AC. Tick mark, where that tick mark, that tells me those sides are congruent. Do you see how to set up the equation now? Okay, so make sure we do that. Go ahead and do that. I'm going to come by and stamp this problem. So I'm going to end up stamping 4, and I'm going to end up stamping 6 when we're done. So I'm going to let you go ahead and work on that. And then I'm going to get us started for the next part. All right, I'll come by and stamp 4, but x should not be greater than 5 if you solved it correctly, the x correctly. Right, need to go to the right side of your page. I want to highlight this theorem because these are some properties that we're going to expect you to recognize and draw the correct conclusion from. So I need you to recognize, first of all, the dotted line that you have here, XB, is a bisector of the angle YXB. XC, excuse me. So this angle right here is your vertex angle. Sorry. And hopefully we see that our triangle is isosceles because of the tick marks right here. Did y'all recognize that? Okay, what conclusion can we draw knowing that XB is a bisector? Yes. Angle 1 is congruent to angle 2. That's the conclusion. What would be our justification, our reason for that? Yeah, we're right over here. Definition of bisector. Okay, so now that I know that, I'm going to go ahead and mark that using definition of a bisector. I'm going to draw conclusions from that line. These are facts that you need to recognize that you're going to have to, once you see that those two angles, your vertex is bisected, two things you have to recognize. One, first thing, this dotted line is always perpendicular, so you would have to add the box. Okay? Meaning XB is perpendicular to the base, which is my YZ. The second thing that always happens, there's two things that happen when I have that bisector. It also bisects the base. So you're going to put 2 tick marks between YB and 2 tick marks between Z. So you could make the conclusion that YB is congruent to BZ. So whenever we see a line that bisects a vertex angle, that line is always a perpendicular bisector. Okay, so one little thing we're going to add to the diagram. In an isosceles triangle, this is called an altitude, which is also known as your height. Your altitude and your height of the triangle are the same. Also, in the isosceles triangle, it is also your perpendicular bisector. It's just a special property for isosceles, which also works with equilateral. Because my question to you, I should do this right. If a triangle is equilateral, then the triangle is isosceles. True or false? True or false? Okay, counterexample. Okay, equilateral triangle. You're right, here we go. That's 3 equal sides. And what does an isosceles triangle have? Do we have at least 2 here? So, this is true. Equilateral, okay, is isosceles. Sometimes. Now, if I did the inverse, the converse of that, the triangle is isosceles, then the triangle is equilateral. True or false? That one is false. Okay? That one is false because a isosceles triangle has at least two sides congruent, right? Equilateral has to have what? Three. Has to have three. Okay, so next thing we're going to look at. Star 5 and 6 for me. Put a star next to 5 and 6 because these are the test-like questions. This is how you would be assessed on isosceles triangles. All right, now I need to fix mine. First of all, on number 6, we need to fix the marking of the triangle. It's missing the congruent angles. So look up here for number 6. I need you to add the markings. Okay. Add your markings to number 6. Number 5 is correct because they put the markings, but they gave a given statement. So you're fine with number 5. So have your markings. Number 5, they tell me angle D is congruent to F. So we're going to add the markings. Since I know that, what can I conclude? The sides are equal. So I'm going to go ahead and put my tick marks to show that the sides are equal. Now that I know the sides are equal, basically I have ED is congruent to EF. I can make that conclusion knowing that the angles are congruent. So how would I write the equation to solve for x? Because they want us to solve for x here. Yes, x squared equals 11x minus 10. We're great there. Now, how are we going to solve this equation? What type is it? Yes, that 2 is very important. It's a quadratic. Now that I know it's a quadratic, what do we have to do? Make it equal to 0. So who are we moving? We need to move the 11x over here, right? And this minus 10 over here. All right, so I'm just going to rewrite it. Always start with your leading coefficient, your highest exponent. So that's why we start with x squared. This is now going to be minus 11x plus 10 equals to 0. This is what I'm going to check. This is the first thing I'm going to check. Did you have it equal to 0? And from here, I want to see your factors. Automatically, because our coefficient, our number in front of x squared is 1, basically, there is no number. The number is 1. We're trying to figure out factors of 10 with the sum of a negative 11. Yeah, negative 10 and a negative 1. So now there's my factors. That's the second thing I'm going to check for. They want us to find the value of x. So x is going to equal, we got to do the opposite of what we're seeing. Yeah, positive 10 and x equals 1. We're going to box that. All right, so with that being said, what we just did for 5, you need to do for number 6. I'm going to come by and stamp that 6 and 4 have been completed, and they are in your spiral. I'm going to give you some time to work on it.